of this lesson, the students will be able to define the manufacture of nitric acid, describe the contact process, define the properties of nitric acid and sulfuric acid.
Molecular weight of nitric acid is 63. Its molecular formula is HNO3. This is also called aqua fortis, which means strong water. During the year 1650, Glauber, a chemist, prepared nitric acid from nitre and sulfuric acid. Lavoisier proved that it contains oxygen in the year 1776. As it was prepared from nitre, it was named as nitric acid. Nitric acid occurs in a free state and also in the combined form. During thunder showers, electric charge will be discharged tremendously in air. This is washed down by rain. Nitrogen and oxygen present in the atmosphere react to form nitric oxide during lightning. This is further oxidized to nitrogen dioxide. Nitrogen dioxide dissolves in moisture present in the atmosphere in the presence of oxygen to form nitric acid. When it rains, nitric acid dissolves with water and falls down as dilute solution, and it gets into the soil and converts into nitrate. The table shows the presence of nitric acid in the combined state in different form of salt. Chile saltpeter is sodium nitrate. Bengal saltpeter or nitre is potassium nitrate. Calcium nitrate is otherwise called lime saltpeter. Ammonium nitrate is Norway saltpeter. Nitric acid is prepared by the distillation of sodium nitrate or potassium nitrate crystals with concentrated sulfuric acid. This method is used to prepare nitric acid in the laboratory. Concentrated sulfuric acid is less volatile than nitric acid, so it is used in the preparation of nitric acid. Concentrated hydrochloric acid cannot be used for this purpose, as it is more volatile than nitric acid. Take a glass retort and take equal mixture of sodium nitrate or potassium nitrate by weight and some concentrated sulfuric acid. Heat the mixture by using a burner to the temperature below 200 degrees Celsius. As nitric acid is volatile than sulfuric acid, it is displaced and vaporized. The vapors are collected in a flask. This flask is kept under running water so that the vapors are condensed. The decomposition of nitric acid is very negligible at ordinary temperature and very high at temperatures higher than 200 degrees Celsius. Due to this property, pure nitric acid is colorless and the acid prepared in the lab is slightly yellowish brown in color. During the decomposition of the nitric acid, a reddish brown nitrogen dioxide is formed. As this is dissolved during condensation, nitric acid gets the yellowish brown color. How to remove this nitrogen dioxide? Carbon dioxide is bubbled through nitric acid to remove nitrogen dioxide from it. It can also be removed by passing dry air into the acid. Air oxidizes nitrogen dioxide into nitric acid. Similarly, when nitric acid is diluted with water, nitrogen dioxide is oxidized into nitric acid. We should follow some precautions while preparing nitric acid. Firstly, the temperature should be retained below 200 degrees Celsius. When the temperature goes up or is below a particular temperature, then different products will be formed. Let us see what happens when the temperature is about 200 degrees Celsius. Sodium nitrate reacts with sodium hydrogen sulfate at temperature about 200 degrees Celsius and form sodium sulfate and nitric acid vapors. Sodium sulfate formed is in a hard crust. At below 200 degrees Celsius, sodium nitrate reacts with concentrated sulfuric acid and forms sodium hydrogen sulfate, which is in a fused state, and nitric acid is also formed. When we see both the reactions, we get nitric acid. Then, why should we maintain the temperature to 200 degrees Celsius during laboratory preparation of nitric acid? This is because nitric acid decomposes on heating into nitrogen dioxide, water vapor, and oxygen. About 200 degrees Celsius, sodium sulfate is formed instead of sodium bisulfate, and this forms a hard crust that sticks to the glass, and it is very hard to remove it and usually results in the breakage of glass. But sodium bisulfate is in the fused form and it is very easy to remove it. The other precautions to be considered are that the nitric acid vapors are corrosive and spoil rubber or cork or metals. Hence, the apparatus used should all be glass materials.
Ostwald's process. This method was established by Wilhelm Ostwald. In this method, nitric acid is manufactured by oxidation of ammonia. The following steps involved in this process: catalytic oxidation of ammonia, a gaseous mixture containing pure and dry ammonia and dust-free dry air in the ratio of 1:10 by volume is passed through a steel shell or aluminium converter having platinum gauze heated electrically to about 1100 Kelvin. Ammonia is oxidized to nitric oxide and the reaction is exothermic. Oxidation of nitric oxide. The nitric oxide is cooled and passed through a spacious chamber called oxidizing chamber. The nitric oxide is oxidized to nitrogen dioxide. Absorption tower. The gases are then introduced in the absorption tower, which is packed with acid-proof stones. Water sprayed from the top dissolves nitrogen dioxide in the presence of oxygen to give about 60% nitric acid. The acid flows down and is withdrawn from the tower with the help of a tap. Further, concentration of nitric acid can be done to 98% acid by dehydration with concentrated sulfuric acid.
When a mixture of ammonia and excess of air is passed over red-hot platinum, we get nitric acid. Ammonia used for this purpose is obtained by Haber's process. The Birkeland-Eyde process also prepares nitric acid. In this process, air is passed through an electric arc so that nitrogen and oxygen in the air combine together to form nitric oxide, and this passes a series of reactions to form nitric acid.
Sulfuric acid. It is the most important oxyacid of sulfur and is known from ancient times. It is called oil of vitriol because in earlier days it has been prepared from ferrous sulfate crystals, green vitriol, and has an oily appearance. It occurs in certain minerals and springs. It is also known as king of chemicals because of its industrial applications. Manufacture of sulfuric acid. Sulfuric acid is manufactured by contact process. The process involves the following steps: production of sulfur dioxide. It is prepared by burning of powdered sulfur or roasting of sulfur-rich ores. Oxidation of sulfur dioxide. This step is key step in the manufacture of sulfuric acid. By applying Le Chatelier's principle. The following step is the key step in the manufacture of sulfur trioxide. Temperature. As the reaction is exothermic, a low temperature favors the forward reaction. An optimum temperature is maintained between 673 to 723 Kelvin. Pressure. A high pressure favors the process. Thus, the optimum pressure of 1.5 to 2 atmospheric pressure is maintained. Catalyst. Platinized asbestos or divanadium pentaoxide is used. Purification of gases. To prevent the poisoning of catalyst, the gases must be free from the impurities of arsenic oxide, dust particles and moisture. Into sulfuric acid. Sulfur trioxide is absorbed in concentrated sulfuric acid to get oleum. Oleum then diluted with calculated quantity of water to get sulfuric acid of required concentration. Following steps involved in the contact process. Sulfur burner. Here, sulfur dioxide is produced. Purification unit. This unit is assembly of various parts like dust participator, which remove the dust from the gases, scrubber, which removes soluble impurities, drying tower, which remove moisture from the gases, arsenic purifier, which removes impurities of arsenic oxide, etc. The gases coming out of the purification unit are passed through the testing box to make sure that they are completely free from the impurities. If impurities are still present, these are recirculated again through the purification unit. The pure gases coming from the testing box are preheated to 673 to 723 Kelvin in a preheater. Catalyst converter. The hot gases are then passed through the catalyst chamber where sulfur dioxide is oxidized to sulfur trioxide. Absorption tower. Sulfur trioxide from the contact tower is introduced at the base of the absorption tower, from the top of which concentrated sulfuric acid is showered. As sulfur trioxide gas moves up, it is dissolved in sulfuric acid, forming oleum. Structure of sulfuric acid. Sulfuric acid is a covalent molecule having hexavalent S atom. It has a tetrahedral structure.